Today we're diving into LeetCode problem 9, Palindrome Number. At first glance, it's a cute number check, but under the hood, it echoes real-world use cases in data validation, secure token scanning, and input normalization. Think of systems that verify mirrored transaction IDs for fast integrity checks. At scale, performance matters. Brute force gets us started. But for tight memory or high-throughput apps, we need a smarter plan. Let's trim the string tricks and build a pure math solution. Let's duck dive into the brute force method first. We'll convert the number to a string, flip it, and check if it reads the same forwards and backwards. Let's walk through that in code. Step 1. Grab the digits in order. We'll convert the integer to a string so we can work with it like an array of characters. With the string in hand, we reverse it to get the backward version. That lets us easily compare it to the original. Now it's just a string match. If the original and reversed versions are equal, we've got a palindrome. This runs in big O of n time and space, where n is the number of digits. For a 7-digit number, it's 7 steps and 7 characters stored. Not bad. But we're paying with extra memory and risking overflow if conversions go wrong. The brute force route works, but let's aim higher. Can we ditch the string altogether? Time to level up with a math-only strategy. First, let's cut off the obvious fails. Any negative number can't be a palindrome, and any number ending in 0, unless it's just 0, breaks the symmetry. With edge cases out, we'll set up a variable to hold the reversed second half of the number. We'll stop once we've mirrored enough digits. We peel off digits one by one from the end, building the reversed half and shrinking the original. We continue while the original is still bigger, meaning we haven't hit the midpoint yet. To handle odd digit counts, we ignore the middle digit if needed. We check whether the original equals the reversed half, or, if there's a middle digit, whether it matches after dropping it. This version runs in big O of log n time and constant space. For 7 digits, that's just 3 to 4 quick steps, super fast, super lean. It skips string handling entirely and handles weird inputs head-on, perfect for interviews and production. We started with the basic path: convert, reverse, compare. It worked, but brought overhead with type conversions and extra space. Then we flipped the game, reversing just half with pure math, cutting time to big O of log n, and slashing space to 0. That's not just theoretical. In real-world systems where strings are slow or banned, this shines. From embedded hardware to back-end APIs, saving memory and cycles matters. And in interviews, showing you know when to ditch strings is a power move. Here's your next challenge. How many problems can you solve without converting to strings? Where else can partial reversal and early exits save the day? If this helped, quack on with more problems that sharpen both your logic and your low-level chops.